Okay, business calculus students, I'm going to open up your test number 2. Okay, so I'm looking at test number 2. In the last video lecture, we worked on some of the problems at the beginning of the test. In this video lecture, why don't we work on some of the problems at the end of the test? So my goal is to work on problems 16 to 22. 16 to 22, okay? So that's actually 7 problems, 16, 17, 18, 19, 20. That's 5 problems, and then 21 and 27, that's 2 more. So we have 7 problems to work on. Okay, so I have Mathematica right over here. Let's look at problem number 16. The total cost in dollars of manufacturing X auto body frames is C of X is equal to 40,000 plus 800X. Part A, find the average cost per unit if 200 frames are produced. Part B, find the marginal average cost at a production level of 200 units. Use the results from parts A and B to estimate the average cost per frame if 201 frames are produced. And actually, the other problems at the end of the test, I believe, are basically very, very similar to this one. But there's nothing wrong with repetition. That's how people learn. You learn through repetition. Okay. So first of all, we're going to define the function c. Mathematica will not allow you to use capital C. So why don't we use lowercase c? C of X is equal to 40,000. By the way, I did not type the comma. This comma right over here, excuse me, this comma was automatically entered for me by Mathematica because of how I configured my copy of the software. Do not enter a comma. I repeat, do not enter a comma. Mathematica entered the comma for me because of how I configured my copy of the software. Do not type the comma. Okay, so 40,000 plus 800 times X. Now, that's the C function. Average C is going to be equal to C of X divided by X, or if you prefer, you can make it look a little fancier by entering control divide by X. Okay, so X is really the number of cars. We could actually say cars, and then this would be the variable cars, and this would be the variable cars. It's the cost, the total cost of the cars divided by the number of cars, and this is the average cost. This is the average cost, okay? So if 200 frames are produced, the average cost is going to be average C, the average cost of 200 cars is $1,000 per frame. What is the marginal average cost at a production level of 200 units? Okay, so we can ask Mathematica to solve this problem, but why don't we try to do this problem by hand? Because you should know how to do it both ways. You should know how to use the computer to solve the problem, but you should also know how to solve the problem by hand. You should know both ways. Okay. Let's see. Let me launch my drawing tool. Here we go. Okay. Okay, so how would we solve the problem by hand? The function, the average cost function is 40,000 plus 800x divided by x. Okay, this is this is the average cost function. So the marginal cost, the marginal average cost is the derivative of the average cost function. So the average, I'm just going to write A, or AVG, AVG for average, is equal to the derivative with respect to x of 40,000 divided by x plus 800. Okay? So we know the derivative of a constant is 0. So we actually, we can forget about the 800. We need to worry about this expression. So what is the derivative of 40,000 divided by x? Well, that's going to be the same thing as 40,000 40,000 times x to the power of -1. And how do I find the derivative of 40,000 times x to the power -1? Why don't we just use the power rule? So that's going to be negative 40,000 times x to the power of -2. And that's going to be the same thing as negative 40,000. I'll put in that comma because I think it looks better. Negative 40,000 divided by x squared. So we can see that the first derivative is always going to be negative. It's always going to be negative. Negative 40,000 divided by x squared. Okay, let me erase that. Does Mathematica agree with us? What is the derivative of the average cost function? I'm differentiating with respect to x, or I could call my variable cars. I can call it whatever I want to call it. Simplify and traditional form, Shift Enter. And indeed, the answer is the same thing. It's negative 40,000 divided by the variable squared. If I want to use x, if I want to call the variable x, that's perfectly acceptable. I can do that too. Okay, call it whatever is appropriate for the problem. Okay, so marginal average, I'm going to abbreviate average, AVG, marginal average cost of x, and x represents the number of cars, is equal to negative 40,000, and once again, I'm not typing the comma, I'm letting Mathematica do that. Control divide by x to the power 2, or to make it look fancier, I can do Control 6, power of 2, okay? Shift Enter. Shift Enter. So for the value of 200, when x, or the number of cars, is 200, what is the marginal average cost? Marginal average cost of 200 is going to be -1. -$1. So if the company makes more than 200 frames, 200, automobile frames for cars, that means the company is going to start losing money, right? Using the results from parts A and B, the estimate of the average cost per frame, if 201 frames are produced, well, the derivative is -1, so it's going to be $1,000 minus $1, so it should be $999. Okay, and let's see if that's true. Yeah, Pearson agrees with me. The answer is 100%. Okay, so why don't we look at the next problem? Okay. So again, this is really the same thing. In fact, I'm not sure if it's really necessary to go up to problem number 22. Problems 16 to 22 are all very similar to each other. So really, I think we'll just go up to problem number 20 because 21 and 22 are basically the same. Okay, so let's look at this. Let's read the problem. The total cost in dollars of producing X food processors is cost of X is 2100 plus 70X minus 0.2X squared. Part A, find the exact cost of producing the 81st food processor. Part B, use the marginal cost to approximate the cost of producing the 81st food processor. Okay, so here we go. Okay, so this problem actually is slightly different. Here we're not talking about the average cost. For the average cost, we're dividing by the independent variable. Here, we don't have to do that because we're not dealing with the average cost. We're dealing with the exact cost. So for problem 17, you don't have to divide by X. In fact, you're not supposed to divide by X. You only divide by X when you are dealing with the average. Here, we're not dealing with the average. There's no need to divide by X. So the cost function that we're given is 2100 plus 70 times X minus 0.2 times X squared. Okay, and what is the derivative of that? Well, it's called the marginal cost. The marginal cost of is going to be the derivative of the cost function with respect to X. Okay. The exact cost of producing the 80. Let me see, 1 second. The exact cost of producing the 81st food processor is cost of 81. Okay, so that's going to be $6,457.80. The exact cost of producing the 81st food processor is $6,457.80. Using the marginal cost, the approximate cost of producing the 81st food processor is, now this one's a little bit challenging because the marginal cost for this problem, I have to put my cursor in the right place. Okay, let's go back to Mathematica. Marginal cost of X. Okay, so the answer here, if X is equal to 81, I'm getting $37.60. I don't think that's the answer that they're looking for. Of course, we can check. So if we take the cost of producing 80 food processors, not 81, but 80, okay? And then we add to that the marginal cost of producing 80 food processors. Oh, wait a minute. Sorry about that. This should actually be X. And then X is replaced with 80. Okay, so here I'm getting a very close answer. I'm getting a good approximation. The answer is going to be $6,458, which is pretty close to $6,457.80. Let's see if Pearson agrees with my answers. Okay, Pearson does not agree with my answers. Oh, I misread the problem. Okay, sorry about that. Okay, hold on 1 second. I misread the problem. The total cost in dollars of producing X food processors is given by this function. The exact cost of producing the 81st food processor, okay, so not the total cost of 81 food processors, but the exact cost of producing the 81st food processor. So that's going to be cost 81 minus cost of 80. And that's going to be $37.80. $37.80. Using the marginal cost, the approximate cost of producing the 81st food processor is going to be, this is where we have to use the derivative. So the marginal cost of X, where X is replaced with 81, is given by $37.60. $37.60. Let's see if Pearson agrees with my answers. Okay, so this time Pearson agrees with one of them and not the other. Okay, unless they're using 80, X is equal to 80 instead of X is equal to 81. In which case, this would be $38. Okay, your input is correct. Score 100%. Okay, so we better review this just to make sure there's no confusion. They're giving you the total cost function, which is given by C of X is 2100 plus 70X minus 0.2X squared. My mistake was in misreading part A. Part A is not find the total cost of producing 81 food processors. The question is find the exact cost of producing the 81st food processor. So to do that, what did I do? I took cost of 81 minus cost of 80, and that gives me $37.80, which is the cost of producing the 81st food processor. Using the marginal cost, the approximate cost of producing the 81st food processor is $38. How did I get that answer? My marginal cost function is the derivative of the cost function, the total cost function. When I replace X with 80, not 81, but 80, the value before They're giving you 81, but you have to use the number before, the integer before, which is 80. Then I'm going to get $38, and that's the answer that they want. Check the answer. It is correct. Score 100%. Okay, let's move on to the next problem. This is pretty similar to problem number 16, but that's okay. Let's go over it. The total cost in dollars of manufacturing X auto body frames is, actually this is just like problem 16, but okay, let's do it anyway. The cost of X is equal to 90,000 plus 300X. Part A, find the average cost per unit if 80 frames are produced. Part B, find the marginal average cost at a production level of 80 units. Part C, use the results from parts A and B to estimate the average cost per frame if 81 frames are produced. Okay, we're going to use Mathematica for this to make things go a little bit faster. I'm going to clear all of my variables in Mathematica. How do I do that? Excuse me. So you're going to clear this. Enter the string, the double quotation marks, global. Okay, this is the symbol below your escape key on your computer's keyboard, and this is the times symbol, the asterisk. Shift enter. Okay. Let's start over again. Cost of X is equal to 90,000 plus 300X. Average cost of X is equal to the cost of X divided by X. And the marginal average cost of X is equal to the derivative of the average cost. And you know what I should do? I should really use some other symbol besides X. Let's use the symbol Y. The average the average cost of Y with respect to Y, and then Y is replaced with X. If 80 frames are produced, the average cost is average cost of 80 is $1,425. The marginal average cost at a production level of 80 units is marginal average cost of 80. Let's change that into a decimal. Round to the nearest cent is needed. So negative $14.06. Using the results from parts A and B, the estimate of the average cost per frame if 81 frames are produced is going to be, so instead, okay, now we could just use the function AVG cost, average cost 81, but that's really not what they want us to do. They want us to use the derivative. So $1,425 minus $14.06. And that's going to be about $1,410.94. That's an approximation. Using the derivative. Let's see if Pearson agrees with me. Your input is correct. Score 100%. So that is correct. Okay, so let's go over quickly what I did. They give you the cost function. Cost of x is equal to 90,000 plus 300x. The average cost is the cost function divided by x. The marginal average cost function is the derivative of the average cost function. For part C, they really don't want you to use the average cost function. They want you to use the marginal cost function to arrive at an approximation of the correct answer. And that's exactly what I did with Mathematica. Let's move on to problems 19 and 20, and then we're going to call it quits for the video. Okay. The profit in dollars from the sale of X lawnmowers is profit of X is equal to 80X minus 0.08 X squared minus 650. Part A, find the average profit per mower if 30 mowers are produced. Part B, find the marginal average profit at a production level of 30 mowers and interpret the results. Part C, use the results from parts A and B to estimate the average profit per mower if not 30, but 31 mowers are produced. Notice they're not interested in 30, they're interested in one more. 31. 31. That's very typical of these problems, okay? That's why you want to use your derivative to approximate the value of the function at the next integer or at the next meaningful value of the independent variable. Okay, so let's use Mathematica to help. So again, clear my variables. Clear my variables. My profit function is given by 80 times x minus 0.08 times x squared, or I can do control 6. That makes it look a little bit nicer the way it looks in a mathematics textbook, minus 650. The average profit is simply going to be the profit divided by x. Remember, that's control divide by on your computer's keyboard. Shift enter. And how do we figure out the derivative? Well, you can figure it out by hand, or you can let Mathematica help. Let me see here. The marginal average profits is simply going to be the derivative of the average profit. Let's use another symbol. I'm using X here. I'll use another symbol here. I'm going to use Y or use any symbol you prefer. And then everything that's Y gets replaced with X. If 30 mowers are produced, the average profit per mower is going to be $55.93. The marginal average profit at a production level of 30 units is marginal average profit of 30. That's about 64 cents. Okay. Choose the correct interpretation of the marginal average profit of 30 is equal to 64 cents per mower. Well, it's very convenient that they gave you, in part C, they're actually giving you the answer to part B, which I thought, well, that's very generous of them to do that. Okay, let's see. Let's read my options. At a production level of 30 mowers, the average profit is increasing at a rate of 64 cents per mower. Let me see. At a production level of 30 mowers, the average profit is, okay, at a production level of 30 mowers, a unit increase in production will increase the total profit. Okay, so we're not interested, we're not interested in total profit for this problem. We're interested in the average profits. So that's why part C is not going to work. Okay, so it's it should be A. At a production level of 30 mowers, the average profit is increasing at a rate of 64 cents per mower. Using parts A and B, the estimate of the average profit per mower if 31 mowers are produced is going to be, it's going to be the answer to part A plus the answer to part B. So we have $55.93 is the answer to part A. And then the answer to part B is going to be 64 cents. So the answer to part C is going to be $56.57. Okay, Pearson agrees with my answer. Score 100%. Okay, terrific. Let's look at problem number 20, and that's going to be the last problem that we do for this video. Okay, problem 20. The price P in dollars and the demand X for a particular clock radio are related by the equation X is equal to 5,000 minus 50P. So P is my independent variable, X is my dependent variable. Let's read this carefully one more time. The price P in dollars and the demand X, so X, demand is a function of price. The price P in dollars and the demand X for a particular clock radio are related by the equation X is equal to 5,000 minus 50P. Express the price P in terms of the demand X and find the domain of this function. Okay, so let's do this one by hand. I mean, I love Mathematica, but sometimes it's good to do certain problems by hand. Mathematica is a wonderful tool, but sometimes it can make people a little bit mathematically lazy. So let's do this one by hand. We have X is equal to, follow my cursor, 5,000 minus 50P. Okay, we have to solve for P. So we have X minus 5,000. X minus 5,000 is equal to negative 50P. That means that 5,000 minus X is equal to 50P. And that means that P is equal to 5,000 minus X divided by 50. P is equal to 5,000 minus X divided by 50. Let's see if that's true. So we have 5,000 minus x. Oops. Let me highlight this entire thing. Divide by 50. What is the domain of x? X represents the demand for a certain piece of merchandise. So we know that x cannot be less, x cannot be less than 0. It wouldn't make sense for there to be a negative demand, and the price cannot be negative. You can't have a negative demand and you can't have a negative price, which means x has to be between 0 and 5,000. All right, if x is less than 0, well, that wouldn't make any sense, because then you have a negative demand for the clock radio, and that doesn't make any sense. And if x is more than 5,000, that means that the clock radio will have a negative price, which means that the company will pay people to use their clock radio, and that wouldn't make any sense. So that means that x has to be between 0 and 5,000. Okay. Now, what is the revenue function here? This one's a little bit tricky. Part C, okay, part B, find the revenue R of X from the sale of X clock radios. So the price P in dollars and the demand X. So price is a function of demand. The revenue is based on the number of clock radios that I actually sell times P. So hold on one second. Let me use my pen. So the revenue function, I have the price P in dollars, and I have the demand X for a particular clock radio, and they are related by the equation demand is equal to 5,000 minus 50 times the price. Now, it makes sense that the revenue would have to be equal to X times P. If that's true, then my revenue, R of P, oh, they're actually looking for R of X. They're actually looking for, okay, hold on one second. Let me erase this. Okay, so we have the function here, P of X is equal to 5,000 minus X. I'm actually writing with my trackpad, so I usually write a little better than this, guys, but this is the best I can do with my trackpad right now. 5,000 minus X divided by 50. 5,000 minus X divided by 50. That is the price P in dollars for the demand X. the price as a function of X, where X is the demand for a particular clock radio. P is the price. Now, if this is actually the price, if this is the price for each clock radio, if I multiply this entire thing by X, that should give me the radio because, not the radio, that should give me the revenue. That should give me the revenue because I have the price multiplied by the demand, and the demand is X. So then the revenue of X is going to be 5,000X minus X squared divided by 50. Okay, that's going to be 5,000X minus X squared divided by 50. Let me enter that into Mathematica. Revenue of X is equal to, hey, I'm just talking to my dog over here, guys, 5,000X minus X squared. Okay, control divide by 50. And that's going to be my revenue function. So my revenue function is going to be, let's see, let me type it into Pearson's little window. 5,000X minus X squared. And we are going to divide that by 50. What is the domain of R of X? Okay, so that's a little bit tricky. Well, we know already from the other function here, we know that the domain is going to be X is between 0 and 5,000. It makes sense to assume that the demand should still be between 0 and 5,000, although it is possible to have a negative revenue. It is possible for a company to have a negative revenue, which is basically the same as a loss. So this problem is a little bit tricky. Because the answer could be X is greater than or equal to 0, or the answer could be X can be any value between 0 and 5,000 inclusive. We're going to find out when we check the answer. I'm going to assume the answer is X is greater than or equal to 0. And the reason I'm assuming that is because it is possible to have a negative revenue. It is possible to lose money on merchandise. It is possible to have a negative revenue, which is a loss. We'll check the answer and we'll find out. The marginal, part C, the marginal revenue at a production level of 4,400 clock radios is, okay, so we need to figure out the derivative of the revenue function. So marginal revenue of X is equal to the derivative of the revenue of X with, use a different symbol, revenue of Y with respect to Y. Now Y is replaced with X. So the marginal revenue of 4,400 is going to be negative $76. Round to the nearest cent is needed. Okay. Oh, you know what? It should be, they're giving you the answer. Okay, wait a minute. The answer should be negative. Okay, so they're giving you, oh, I see. They're using a different number over here. No wonder. Okay, let me check something right over here. So it says here, part D, which of the following statements is not a correct interpretation of the marginal revenue of 4,800 is equal to negative $92? Okay, I want to use my function to make sure I have the same number that they have. So marginal revenue of $4,800. Okay, terrific. That's sensational. So I'm getting negative $92, which means that my marginal revenue function and hence my revenue function are both correct because my numbers agree with the numbers in your textbook. So that's a good sign. Which of the following statements is not a correct interpretation of the marginal revenue of 4,800 is equal to negative $92? At a production level of 4,800 clock radios, the change in revenue per unit change in production is approximately negative $92. The total revenue for producing 4,801 clock radios is approximately $92 less than the total revenue for producing 4,800 clock radios. If 4,800 clock radios are produced, there will be no revenue since the marginal revenue or the derivative of the revenue function of 4,800 evaluated at x is equal to 4,800 is negative. So B is definitely the answer they're looking for. And the reason why B is the right answer is because it offers an incorrect interpretation of the derivative. They're talking about total revenue. We're not interested in total revenue in this problem. We're interested only in marginal revenue, which is the derivative of the revenue function. It is not the derivative of the total revenue function. So that should be the answer. Now, let's see if everything is okay. Okay, so they're giving me almost 70% here, which means there's something here they don't like. And I have a feeling it's my answer to part B. I think the answer they're looking for is x has to be between 0 and 5,000. And the reason is because the answer for part A is the domain of x is such that x has to be between 0 and 5,000, which is logical. So here the domain of the revenue of x should also be x is between 0 and 5,000. So I believe that was a little mistake that I made. Now let's check if Pearson agrees with my answer. Okay, well this is, so my score went up to 83.33%. Let's see what they do not agree with. Everything here should be okay. For some reason, let me check one thing over here. Oops, there, wait a minute. Marginal revenue of $4,400. Okay, that should be correct. Negative 70, well, you know what, maybe I'm supposed to add 2 zeros over here, but I don't think that would really change anything. Okay, so Pearson is still giving me an 83.33% on this question, which is a little bit strange. Hmm. Interesting. Everything should be okay. So what I'm going to do is I'm going to submit this, and then we're going to look at the answer for question number 20. So there's something in my answer that Pearson doesn't like, and I'm curious to find out what it is. So submit this. Yeah, I realize that. Oh, I have 2 unanswered questions. No wonder I'm getting partial credit. Um, wait, what are my 2 unanswered questions? Wait a second. Okay, part A, part B, part C. Okay, why everything looks fine. Yeah, so they're complaining. Pearson is complaining because I didn't actually finish the test, but that's okay. I'm not taking the entire test. I only answered certain questions. So let's submit this. Let's go to problem number 20. So Pearson agrees with my answer to part A. Oh, interesting. Oh, so you know what happened? I think for part D, I made a mistake and I just clicked on the total revenue for producing 40. Okay, so this is actually the correct answer, which is what I meant to select in the first place, is if 4,800 clock radios are produced, there will be no revenue since, well, actually, okay, so what they're looking for, what they really wanted was the answer to D. The answer to D is option C. If 4,800 clock radios are produced, there will be no revenue since the derivative of 4,800 is negative. I kind of agree with that statement, but they're saying that that's not a correct interpretation of this derivative. What I selected was the total revenue for producing 4,801 clock radios is approximately $92 less than the total revenue for producing 4,800 clock radios. So what they're suggesting then is that this is the correct interpretation, and C is not the correct interpretation. Okay, but they accepted, Pearson accepted my other answers, so most of it was indeed correct. Okay, so hopefully that will help you with your test. Remember, if you don't do well, if you fail the test the first time you take it, you have the option of repeating the test. So let me repeat that. Let me say that one more time. If you fail the exam the first time, you have the option of reviewing your work, reviewing your test answers, and then you can go into Pearson and retake your test in order to try to get a higher score. Okay? So I'm allowing everyone in the class 2 attempts to take the test. You have 2 attempts to take the test. And I strongly encourage everyone in the class, excuse me, I strongly encourage everyone in the class to use Mathematica, because if used properly, Mathematica will really help you tremendously and will allow you to get through these problems much faster. Mathematica can make this entire process go much faster. You will finish the homework faster. You will finish your quizzes faster. You will finish your tests faster if you take the time to learn how to use Mathematica the way that it should be used. All right, okay, I think this video has gotten long enough, and I hope that it helped you at least a little bit. Thank you, and good luck with your test.